In previous grades, we have seen that unless we have a ruler, there is no way to find the lengths of different sides of a triangle. But now we can find the length of an unknown side of a right angle triangle. And to do this, we use Pythagoras' theorem. So let's draw in a triangle, and we can name it A, B, C. Please remember that this method only works with right angle triangles. If a triangle does not have a right angle, you cannot use Pythagoras' theorem. So let's draw in a curve up here for angle A and for angle B. Now, from our introductory video to angles, we said that we draw a square angle to show that it is 90 degrees. So let's say that C is 90 degrees. We can draw our square angle in red. A right angle triangle will always have a 90-degree angle. It does not matter where the angle lies or how the triangle is drawn. The square angle is always the 90-degree angle. The hypotenuse is always directly opposite the 90-degree angle. So here, C is our 90-degree angle. So the side directly opposite it is the hypotenuse. It does not matter where the triangle is drawn, how the triangle is drawn, or where the 90-degree angle lies. The hypotenuse will always be on the side that lies directly opposite the 90-degree angle. Next, let's name our sides. In our introductory video to triangles, we said that we name a side by the letter of the vertex that lies directly opposite. We can name the side directly opposite vertex A as lowercase a, and we can name the side directly opposite vertex B as lowercase b. We know the side directly opposite from the 90-degree angle is the hypotenuse, but you don't have to write hypotenuse on your diagram. To make it easier, we simply write h. Now, Pythagoras' theorem states that if you take side A, square it, and add the square of side B, you will get the square of the hypotenuse. But the square of a length doesn't help us. So to find the length of the hypotenuse, h by itself, we need to square root. And remember, what you do to one side, you do to the other. So let's square root this side. And now on the left, we have a squared plus b squared under a square root. On the right, the square and the root will cancel, and we're left with h. Please keep in mind the hypotenuse will always be h, but it doesn't matter which side you assign to A and to B. With this in mind, let's write our theorem up here, and now we can look at some examples. Determine the value of h in the following triangles. In this triangle, h is the unknown length of the hypotenuse. This triangle has one side with a length of 4 units and one side with a length of 3 units. So let's say that this side is A and this side is B. Now to find h, we say the hypotenuse h is equal to the length of side A, 4, squared, plus the length of side B, 3, squared, all under a square root. And now we can simplify. 4 squared gives us 16, plus 3 squared, which is 9, under a square root. 16 plus 9 gives us 25, under a square root. And we know that the square root of 25 is 5. This is the length of the hypotenuse h. Let's do another one. Again, h is the unknown length of the hypotenuse. Let's say that side A is down here and side B is over here. So now we say the hypotenuse H is equal to the length of side A, 20, squared, plus the length of side B, 15, squared, all under a square root. Now to calculate H, you don't need to calculate each step. It's much easier to put this straight into your calculator. So let's take our calculator and we say the square root of 20 squared plus 15 squared is equal to 25. This is the length of H. We can write this down here. Let's do one more. In this example, H is still the unknown length of the hypotenuse, and we can see that this side is 3. But what about the bottom side? We've seen in our previous videos that we use small lines to show equal sides on a diagram. We have a small blue line over here and over here. This means that both sides must be equal to 3. So let's put a 3 in our diagram down here. Now we can write the equation for H. So we say the hypotenuse H is equal to the length of our first side, 3, so we say 3 squared, plus the length of our second side, it's also 3, so we say 3 squared, all under a square root. Now we can take our calculator and we say the square root of 3 squared plus 3 squared is equal to, let's change this to decimals, and we get 4,2426, which means that the hypotenuse H is equal to 4,24 to 2 decimal places. Now, to use Pythagoras' theorem, we need to have 2 known sides of a right angled triangle, and we can then find the unknown third side. But what happens if our unknown side is not the hypotenuse? Let's say that we have the equation A plus B is equal to C. But now we want to solve for A. To do this, we need to get A by itself. So we move B to the right-hand side. Now on the left, we have A is equal to C, which is already there. We're moving B to the right, so we say minus B. We can use this idea when using Pythagoras' theorem as well. We know that A squared plus B squared is equal to the hypotenuse H squared. But what if we need to find the unknown side A? We simply move B squared to the right. So now we'll have A squared is equal to the hypotenuse H, which is already on the right, squared. We're going to move B squared, so we say minus B squared. Then, to get A by itself, we square root both sides. On the left, the square and the root will cancel, and we're left with A is equal to the hypotenuse squared minus B squared, all under a square root. If the unknown side is not the hypotenuse, all we do is subtract the square of the other known side from the square of the hypotenuse. Let's put our formula up here, and we can look at some examples. Determine the value of x in the following triangle. Here we have a 90-degree angle at B, which means that AC is our hypotenuse and has a length of 13 centimeters. We also have another known side of 5 centimeters. Now we need to find x. So we can say the unknown side x is equal to the length of the hypotenuse, 13. So we say 13 squared minus the length of the known side, 5, so we say 5 squared, all under a square root. Now we can simplify. Under our root, we have 13 squared, which gives us 169, minus 5 squared, which is 25, all under a square root. 169 minus 25 gives us 144 under a square root. Finally, let's square root 144, and we get an answer of 12. This is the value of side x. Let's do another one. Here we can see that angle E is our 90-degree angle, which means that DF is our hypotenuse that is 45 units long. We also have another known value of 27 units. So to find the value of x, we say x is equal to the length of the hypotenuse, 45 units, squared, minus the length of a known side, 27, squared, all under a square root. These are very big numbers, so let's put them into our calculator. Now we can say the square root of 45 squared minus 27 squared is equal to 36. This is the length of our unknown side. Let's do another one. Consider the diagram and solve for x and for y. Here we have two unknown values that we need to find. Now you don't have to find the unknown values in alphabetical order. We just need to use the information we've been given. X lies on triangle GHI. So let's make this triangle blue. I is the 90-degree angle, and the side GH lies directly across from it, which means that this triangle GH, no. Let's go again from here, sorry. I is the 90-degree angle, and the side GH lies directly across from it, which means that in triangle, let's go again from here, sorry. I is the 90-degree angle, and the side GH lies directly across from it, which means that in this triangle, GH is the hypotenuse with a length of 15 units. We also have side HI with 9 units, and we can see that these known sides, let's go and do all that again, sorry. Begin here. I is the 90-degree angle, and the side GH lies directly across from it, which means that in this triangle, GH is the hypotenuse with a length of 15 units. We also have side HI with a length of 9 units, and we can use these known sides to find the value of x. We have the hypotenuse, and we have one known side. So now we can say x is equal to the length of the hypotenuse, 15 units, so we say 15 squared, minus the length of the other known side, 9 squared, all under a square root. Now we can take our calculator and we say the square root of 15 squared minus 9 squared is equal to 12. This is the length of x. Now let's tidy up our diagram. We know that x is 12 units long, so we can make a note of it down here, and we can put it into our diagram as well. Now we need to find the value of y. Y lies in the triangle GIJ. So let's make this triangle blue. In this triangle, G is the 90-degree angle, and y lies directly opposite it. So in this triangle, y is the length of the hypotenuse. we have two known sides. GJ is 5 units long, and we've just found that GI is 12 units long. So we can use these known sides to find the value of y. Now we can say the hypotenuse, which in this case is y, is equal to, let's call GI side A, so we say 12 squared, plus side B, 5 units, 5 squared, all under a square root. And now we can take our calculator and we say the square root of 12 squared plus 5 squared is equal to 13. This is the value of y. Let's do one more example that's a little trickier. Determine the value of x in the following triangle. The unknown value of x lies up here in triangle KNM. So let's make this triangle blue. M is a 90-degree angle and x lies directly across from it, which shows us that x is the hypotenuse in this triangle. But in order to find the length of the hypotenuse, you have to know the length of the other two sides of the triangle. Here we can see that we don't have the length of KM, and the 39 units down here applies to the whole side from L to N. So we don't have the side of MN either. From this, we can see that in order to find x, we first need the side of KM and the length of side MN. So let's take the blue triangle away. Let's start with MN. From the diagram, we can see that LN is 39 units long. We can also see that LN is made up of the length of LM and MN. So we can say LM plus MN is equal to 39 units. But we don't want LN. We want the length of MN. So let's make this side blue. Now we can rearrange our equation to solve for MN. So we can say MN is equal to 39. I'm going to move LM to the right, and we get minus LM. The diagram shows us that LM is 7 units long. So we can know that MN is equal to 39 units minus LM, which is 7. And we get 32 units. This is the length of MN. Now we can make some space, and let's put 32 units in our diagram for MN. Let's take our blue line out as well. Before we move on, there's one more thing we need to consider. LMN is a straight line, and we know that a straight line has an angle of 180 degrees. If angle M is 90 degrees, then this side of M must be 90 degrees as well. So let's draw a right angle in red. We're going to use this to find the length of KM, because now KM is one side of the right angle triangle KLM. So let's make this triangle blue. M is the 90-degree angle, and directly across from it is KL, which is 25 units long. This is the hypotenuse of triangle KLM. Now we have an hypotenuse of 25 units and a known side of 7. And we can use these values to find the length of KM. So we can say KM is equal to the hypotenuse, 25 squared, minus the length of our known side, 7 squared, all under a square root. Now we can take our calculator and we say the square root of 25 squared minus 7 squared is equal to 24. This is the length of km. Now we can make some space and take out the blue triangle. We just found that km is 24 units long. So let's put this into our diagram. Now we have the length of mn and the length of km. So now we can solve for x. Let's make triangle KMN blue. X lies directly across from the 90-degree angle at M. So x is the hypotenuse of this triangle. So to find the value of x, we can say the hypotenuse, which in this case is x, is equal to the length of one known side. Let's use MN, 32 units. So we say 32 units squared, plus our other known side, km, 24 units. So we say 24 squared, all under a square root. Now we can take our calculator and we say the square root of 32 squared plus 24 squared is equal to 40. This is the length of x, and we have now completed this question.